बिस्मिल्लाहिर्रहमानिर्रहीम अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मदिन व बारिक वसल्लिम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़्दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Omar Farooq. In the previous lecture, we became aware of the fact that chemistry is the study of matter. Then we found the answer of the question, what is matter composed of? Obviously, chemistry has the answer, as it deals with the study of matter. Let's remove the last 3 points as we are interested in the first one, that is, how the matter is composed. Experiments have revealed that every matter consists of very tiny particles. These particles may or may not exist freely. By free existence of a particle, we mean that the particle can exist alone as a single unit without depending on other particles. And if a particle does not exist freely, it means that the particle is unstable as a single unit and exists only by combining with other particles. So all matter consists of tiny particles which may or may not exist independently. And these particles are atoms, ions, molecules, and formula units. In today's lecture, we will try to understand what these particles are. So today's lecture is about the particles of the matter. First of all, atom. In the previous lecture, we talked about atom in detail. Just to give you a brief glimpse, an atom is the smallest particle of an element which may or may not exist independently and can take part in a chemical reaction. An atom has two main parts, that is, nucleus and shells. The nucleus is composed of protons and neutrons. Positively charged particles are called protons, while neutrons carry no charge. Negatively charged particles, called electrons, revolve around the nucleus in shells. Remember, in an atom, the number of electrons is always equal to the number of protons. That's why it is a neutral particle overall. Only the atoms of noble gases exist independently, whereas the atoms of rest of the elements either form ions, molecules, or formula units to gain stability. So next in the list is ions. An atom having a positive or negative charge is called an ion. As you know that an atom is a neutral particle as a whole, as it has equal number of protons and electrons. But what happens if this balance is disturbed? Obviously, it does not remain neutral at all. That is, it acquires some charge. Loss of electron creates a positive charge on it, whereas gain of electron creates negative charge. This charged atom is called ion. So there are two types of ions, positive ion or cation and negative ion, also called anion. Positive ion. An atom having positive charge is called positive ion or cation. A positive ion is formed when an atom loses one or more electrons. This is shown by the general equation in which an atom A carrying 0 charge acquires n positive charge by losing n electrons, where n may be 1, 2, 3 and so on. For example, consider an atom having 5 protons and 5 electrons. Charge of each proton is cancelled out by the charge of each electron. That's why it is neutral and therefore called an atom. Now, if this atom loses an electron, then the charge of 4 protons is cancelled out by the charge of remaining 4 electrons, whereas the charge of 5th proton is not cancelled out. So this atom is now called an ion, as it is not neutral at all and acquires 1 positive charge. Hence, it is also called unipositive ion. If this atom loses 2 electrons, then the charge of 3 protons is cancelled out by the charge of remaining 3 electrons, and the charge of these 2 protons is not cancelled out. Therefore, it is called a dipositive ion, which is shown by this equation. Similarly, if this atom loses 3 electrons, then the charge of 2 protons is cancelled out and the atom acquires 3 positive charge, therefore called tripositive ion. For example, hydrogen atom loses 1 electron to form unipositive ion. Similarly, sodium also loses 1 electron to form unipositive ion. And magnesium loses 2 electrons to form dipositive ion, while aluminium loses 3 electrons to form tripositive ion. Negative ion. An atom having negative charge is called negative ion or anion. A negative ion is formed when an atom gains 1 or more electrons. This is shown by this general equation in which an atom B, which carries 0 charge, acquires n negative charge by gaining n electrons, where n may be 1, 2, 3 and so on. Consider again the same atom. This is a neutral atom. If this atom gains 1 electron, then its charge is not cancelled out. Therefore, it forms an ion, and the atom acquires 1 negative charge on it, so it is called uninegative ion. Similarly, if this atom absorbs 2 electrons, then their charge is not cancelled out and this atom forms dinegative ion. And by gaining 3 electrons, it becomes trinegative ion. For example, chlorine atom absorbs 1 electron to form chloride ion, oxygen atom absorbs 2 electrons to form oxide ion, whereas nitrogen atom absorbs 3 electrons to form nitride ion. Positive ions are also called positive radicals and negative ions the negative radicals. An ionic compound, for example sodium chloride, is formed when oppositely charged ions join through strong electrostatic force called ionic bond. Here we have sodium atom having 11 electrons, 2 in first shell, 8 in the second, and 1 electron in the outermost shell. On the other side, we have chlorine atom containing 17 electrons, that is 2 in first, 8 in the second, and 7 in the outermost shell. Sodium atom has 1 electron in excess, whereas chlorine atom is deficient of 1 electron. Now sodium atom loses its outermost shell electron to the chlorine atom. In this way, sodium atom forms positive ion, Na positive, while chlorine atom becomes Cl negative ion. This is shown by the chemical equations. Sodium atom loses 1 electron, which is absorbed in the chlorine atom. So both form ions, which attract each other so strongly that they form an ionic compound, sodium chloride. Here NaCl is the formula unit of its structure. Similarly, magnesium chloride is formed when magnesium atom containing 2 electrons in its outermost shell transfers its electrons in the outermost shells of 2 chlorine atoms. In this way, magnesium atom forms magnesium 2 positive ion and each chlorine atom forms chloride ion. This is shown by the chemical equation. Magnesium atom loses 2 electrons which are absorbed in 2 chlorine atoms and they form magnesium chloride. The formula unit of magnesium chloride is MgCl2. Let us differentiate the two important particles of matter, atoms and ions. An atom is the smallest particle of an element, whereas the ion is the smallest unit of an ionic compound. An atom may or may not exist independently and can take part in a chemical reaction, while an ion never exists independently and it is always surrounded by oppositely charged ion. An atom is electrically neutral, whereas an ion has a net charge, either positive or negative. So next in the list is molecules. A molecule is the smallest particle of an element or a compound that can exist independently or freely and shows all the properties of that substance. We'll talk about element, compound, mixture and substance in detail in the next lecture, but for the time being I just define compound. When two or more atoms of different elements chemically combine through ionic or covalent bonds in a fixed ratio by mass, the new substance formed is called compound. A molecule is usually a combination of two or more atoms of the same or different elements. But a single atom can be a molecule if its outermost shell is full to its maximum capacity. For example, atoms of noble gases are molecules in the atomic form. They do not need to combine with other atoms. That's why they are called monoatomic molecules. Mono means one. The type of a molecule is decided either on the basis of number of atoms forming molecules or on the basis of type of atoms which form a molecule. On the basis of number of atoms, we have monoatomic molecules first, which consists of one atom only. For example, atoms of noble gases exist as monoatomic molecules. Next is diatomic molecules, which consists of two atoms. For example, H2, F2, Cl2, Br2, I2, O2, N2, CO, NO, HBr, HI, etc. The number 2 in the subscript represents number of atoms in the molecules. The molecules H2, F2, Cl2, Br2, I2, O2 and N2 in the list are the molecules of elements, whereas the molecules CO, NO, HBr, HI contain two atoms from different elements. So they are the molecules of compounds. Then we have triatomic molecules, which consists of three atoms. For example, O3, H2O, CO2, SO2, NO2, H2S, etc. O3 is a molecule of an element, oxygen, while rest are the molecules of compounds. Similarly, tetraatomic molecules consists of four atoms. For example, P4NH3, PH3, C2H2, SO3, etc. In this list, we have P4 as a molecule of an element, whereas the rest of the molecules are the molecules of compounds. The term polyatomic molecule is used for all those molecules which consists of three or more atoms. For example, O3, H2O, CO2, etc. This means that triatomic, tetraatomic, pentatomic, hexaatomic, and higher molecules are all polyatomic, but monoatomic and diatomic molecules are not. On the basis of type of atoms, we have two broad categories of molecules, that is homoatomic molecules and heteroatomic molecules. Homoatomic molecules have same type of atoms. Homo means same, whereas heteroatomic molecules have different type of atoms. Here the word hetero means different. For example, the molecules of elements are the homoatomic molecules, whereas the molecules of compounds are the examples of heteroatomic molecules, because each molecule is formed by the atoms of different elements. So they are the molecules of compounds, heteroatomic molecules. Molecules of elements, that is homoatomic molecules, are formed when atoms of the same element join through strong force called covalent bond. Let's have a closer look on such molecules. For example, molecule of nitrogen consists of two nitrogen atoms. Oxygen forms diatomic molecule, that is O2. Molecule of ozone is formed by three oxygen atoms. A chlorine molecule is formed by two atoms of chlorine. Phosphorus forms tetraatomic molecule, that is P4, whereas sulfur forms octatomic molecule S8, which consists of 8 atoms. On the other hand, molecules of compounds, that is heteroatomic molecules, are formed when atoms of different elements join through covalent bond. For example, HCl molecule, hydrogen chloride. This is the molecule of hydrogen bromide, HBr. The smaller atom is of hydrogen. This is molecule of hydrogen iodide. This is water molecule, H2O. The red atom represents oxygen atom, whereas the two small atoms represent hydrogen atoms. These are the molecules of carbon monoxide and carbon dioxide. Then we have molecule of methane, CH4, ammonia, NH3, benzene, C6H6. The gray atoms, 6 gray atoms represent 6 carbon atoms, whereas the 6 yellow atoms, each bonded to each carbon atom, represent hydrogen atom. This is molecule of sulfur trioxide. The yellow atom represents sulfur, whereas the 3 red atoms represent oxygen atoms. This is sulfur dioxide molecule. And here we have molecule of sulfuric acid. The central yellow atom represents sulfur, whereas the 4 red atoms represent oxygen atoms, and the white atoms, 2 white atoms, represent hydrogen atoms, H2SO4. And finally, we have formula units in the list of particles of matter. Let me remind you again, what is a compound? When atoms of 2 or more elements chemically combine through ionic or covalent bonds in a fixed ratio by mass, the new substance formed is called compound. Look at this flow chart carefully. On the basis of bonding, compounds are classified as ionic compounds and covalent compounds. Ionic compounds are formed by electron transfer from one atom to another, while covalent compounds involve mutual sharing of electrons. Covalent compounds are further classified as molecular covalent compounds and network covalent compounds. Molecular covalent compounds as the name suggests, consists of independent particles called molecules, whereas ionic compounds and network covalent compounds both have formula unit as their smallest unit. Ionic compounds are formed when oppositely charged ions join through strong electrostatic force called ionic bond. For example, sodium chloride. Sodium chloride forms a huge building of sodium ions and chloride ions, in which each sodium ion is surrounded by and strongly attracted by 6 chloride ions. Similarly, each chloride ion is surrounded by 6 sodium ions, and therefore its single unit NaCl does not exist freely. So NaCl cannot be called as molecule, rather it is the formula unit of sodium chloride, that is the unit of chemical formula of sodium chloride. Let's peep inside this huge and tall building of sodium chloride. You see that if one unit of sodium chloride, that is NaCl, wishes to exist as free independent molecule, it cannot, as each ion is surrounded by oppositely charged ions by strong electrostatic forces. So NaCl lives as a part of this crystal. Therefore, NaCl is not a molecule of sodium chloride, rather it is the formula unit. Similarly, network covalent compounds also consist of formula units. Network covalent compounds are formed when atoms of different elements join together through covalent bonds to give a joint structure. For example, silicon dioxide, commonly known as sand. This is the structure of silicon dioxide, in which cyan colored atoms represent silicon and brown colored atoms represent oxygen. We are now in a position to define formula unit. The smallest unit of a compound which repeats throughout its structure is called its formula unit. A chemical formula shows the kinds and numbers of atoms in the smallest representative unit of a substance. Ionic compounds and covalent network solids do not exist as individual molecules. A formula unit is thus indicates the lowest possible ratio of cations and anions of an ionic compound. For example, table salt, sodium chloride, has a formula unit of NaCl, meaning that the sodium and chloride ions are in a 1:1 ratio. Another example is aluminium sulfate, having a formula unit of Al2SO4 thrice. This indicates that the aluminium and sulfate ions are in a 2:3 ratio. That is, 2 ions of aluminium combined with 3 ions of sulfate. An example of covalent networks is sand, that is silicon dioxide, having a formula unit of SiO2. This indicates that the silicon and oxygen atoms are in a 1:2 ratio. Formula unit helps us in deciding the chemical formula for a compound, as it is the unit that represents an entire compound. Later we will study about chemical formula. By this time you have probably observed that the smallest unit of both element and compound may be of two types on the basis of its existence. If the smallest unit of both element and compound exists freely, it is called a molecule. If the smallest unit of an element does not exist freely, it is called an atom. And if the smallest unit of a compound does not exist freely, it is called a formula unit. If you have any questions, please do write in the comments below. Thank you.